Hi guys, greetings to you all. I would like us to look at the nature of roots of a quadratic equation. A quadratic equation has two roots, okay? But the nature of roots now, we are talking, are the roots real? Are the roots real and equal? Are the roots distinct? Are the roots imaginary? And this will depend on the discriminant b squared minus 4ac. So the discriminant, which is b squared minus 4ac, in the quadratic formula will help us determine the nature of roots that we have. If b squared minus 4ac is greater than 0, we have real and distinct roots. If it is equal to 0, we have what we call equal roots or repeated roots. And if b squared minus 4ac is less than 0, less than 0 means negative. We have the square root of negative, so we are talking about complex roots or imaginary roots. And if we talk about real roots, real, real is merging distinct and is merging with equal. That's why we talk about greater than or equal to 0. Now talking about this one, let lambda be a real constant. Show that the roots of the quadratic equation 3x squared plus negative 4 minus 2 lambda x plus 2 lambda equal to 0. The very first thing that is good to obtain here is to verify, to know the values of a. A in a quadratic is a coefficient of x squared. So we have a here, which is 3. B here is a coefficient of x. Remember, lambda is a constant, so our x is this. So we have negative 4 minus 2 lambda. Then our c is 2 lambda. So to show that the roots are always real, you have not been asked to find the values of lambda for which the roots are real. No. I have not been asked that range of values. But to show that the roots are always real for any value of lambda. Okay. So we have our b squared minus 4ac, which is negative 4 minus 2 lambda, all that square, that is negative 4 times this also, minus 4 times 3 times 2 lambda. Negative 4 times negative 4, 16, plus 8 lambda, plus 8 lambda, plus 4 lambda squared. Now this one is negative 12, that's minus 24 lambda. We are not here writing that greater than or equal to 0. No, it is from our result that we'll know whether it is greater than or equal to, collect like terms. 8 plus 8 lambda plus 8 lambda, 16. 16 lambda minus 24 lambda gives us negative 8 lambda plus 16. Now what do we notice here? That 4 is common. So we have lambda square minus 2 lambda plus 4. Now, observing this, you notice that lambda square minus 2 lambda plus 4 is simply lambda minus 2 all that square. Lambda minus 2 all that square. Hope we are able to notice that well. Lambda minus 2 all that square, which means, which is always what? Greater than 0. If you look at it, whatever the value of lambda, lambda minus 2 squared, because squaring means positive, you always remain positive. And a positive number times 4, which is a positive number, it makes all of this will be greater than or equal to 0. So it gives us the value here greater than or equal to 0. Okay, so we have here greater than equal to 0, and that is our proof. All right, now okay, like here question 2 says, given that the roots of the equation are, we have here, yes, k plus 5, okay, k plus 5 minus 10x plus 2k equal to 9k. Now the first thing to do here is to arrange it. Where we rearrange, we have this. Arrange it, our x here is common. You have negative 10 plus 2k into x minus 9k equal to 0. Alright, minus 9k equal to 0. Okay, so when you collect the like terms, we have 4 equal roots. We know that b squared minus 4 is equal to 0, which we have that. Now expanding, negative 10 plus 2k is negative 10 times negative 10, 100. Negative 10 times 2k, negative 20k. 2k times negative 10, negative 20k. And here we have negative 4 times negative 946k. When you rearrange, you have this. Now, what are the factors of 2 times 5, 10? So what are the factors that will add to give 7 and multiply to give 10? So we have here 2k squared plus 2k plus 5k plus 5 equal to 0, which is 2k k plus 2. Right, 2k here, yes, okay, k plus 1, sorry, k plus 1 plus 5k plus 1 equal to 0, which gives k plus times k plus 1 equal to 0. So our k will be negative 1, or k is negative 5 over 2. Okay, thank you. So you see the nature of roots. Here we have seen an example on equal roots. Stay tuned for more videos.